Hi everyone. Today we're going to have a short lesson on identifying types of chemical equations. As you can see on your screen, this is a synthesis reaction. So in a synthesis reaction, you have two reactants, and those reactants could be an element or a compound. Same thing for the second one, could be an element or a compound. And they will combine to form a single product. So in a synthesis reaction, you have two things coming together to make a single product. Our second type of reaction is called a decomposition reaction. In a decomposition reaction, you have a compound on the reactant side, on the left side of your equation, and that compound breaks down into two or more, could be two, could be three, new products, and those new products could be elements or compounds. So element or compound, same thing for the second one. So a single reactant breaks down into two or more products. Our third type of reaction is called a single replacement reaction. In a single replacement reaction, you have an element reacting with a compound and replacing a part of that compound. And as a result, you form a new compound and a different element. So in our case, we have a compound here reacting with an element. This element is going to replace part of our compound. As you can see here, that'll form a new compound and a different element. So whatever element this is, it was the one that was originally part of the compound in the beginning. And the element that was by itself at the beginning is now part of this new compound. Our fourth type of reaction is called a double replacement reaction. And basically what happens in a double replacement reaction is that two compounds will react with each other and they will switch partners. So the cation from one will pair up with the anion from the other, so the positive of one with the negative of the other, and same thing. So in this case, A will combine with Y, and B will combine with X. So our new products are going to be AY and BX. So in these types of problems, we need two compounds, and we form two new compounds. Our fifth and final type of chemical reaction is very specific. It is called a combustion reaction. And every combustion reaction has three parts that are always going to be the same. So in a combustion reaction, you're always going to combine with oxygen, and you're always going to produce carbon dioxide and water. It's very easy to recognize a combustion reaction because it always has these three parts the same. The first part, and this is the part that differs, this is called a hydrocarbon. Hydrocarbon is a compound that is made from hydrogen, carbon, and sometimes oxygen. So if you see a hydrocarbon, something that has carbon and hydrogen, reacting with oxygen to produce carbon dioxide and water, that is an example of a combustion reaction.
Okay, at this point, we're going to take a look at a few equations as we go through some of these answers. So looking at our first reaction here, we have carbon plus oxygen, so an element plus another element forming a single compound. So if we have two elements forming a single compound, that is an example of a synthesis reaction. Let's take a look at our second example. we have a compound, C2H2, plus an element forming a single compound. Again, an example of a synthesis reaction. In our third example, we have a single reactant, C2H6. That reactant is breaking apart into a compound and an element. This is an example of a decomposition reaction, when we have a single compound breaking up into more than one, so either an element and an element, or two compounds, two new compounds, or a compound and an element like we have in this case. In our fourth example, we have a compound, C2H6, reacting with oxygen, producing carbon dioxide and water. In this case, we have a combustion reaction. Note, anytime, and we're always looking for this, anytime we see oxygen, carbon dioxide, and water, we're going to have a combustion reaction. Take a look at the next example. Again, we see oxygen, we see carbon dioxide, and water. So we have another example of a combustion reaction here. Let's take a look at a few more examples. So if we go to the next slide, you're going to see that we have N2 plus H2 going to form NH3. So in this case, we have a synthesis reaction, two elements coming together to form a single product. In our next example, we have just one reactant here on the left side, and we have a compound and an element on the right side. So this is an example of a decomposition reaction. We have a single thing breaking down into parts. Okay, in our third example on this slide, we have a compound and an element forming a new compound and a new element. This is an example of a single replacement reaction. In this case, fluorine is replacing chlorine in our compound. And as a result, we wind up with sodium fluoride instead of sodium chloride, and we end up with chlorine by itself instead of fluorine by itself. In our next example, we have another synthesis reaction, two elements combining to form a single product. Our fifth example, we have a double replacement reaction, one compound and another compound forming two new compounds. Notice that PB is now paired up with Cl as PbCl2, and H over here is paired up with OH to make water. So this is an example of a double replacement reaction. The next example is another double replacement reaction. We have aluminum pairing up with sulfate to give us aluminum sulfate, and we have potassium pairing up with bromine to give us potassium bromide. So another double replacement example. And finally, our last example, we have methane, so it's carbon and hydrogen, combining with oxygen, giving us carbon dioxide and water. So if you guessed combustion reaction, you are correct. All right, I hope everyone has a great week, and please let me know if you have any questions.